Hi there. Today, me and Hamza will be talking about thermodynamics table. It's about our thermodynamics project. We'll be explaining how thermodynamics tables work and how to find values and how to solve problems depending on all those values. In order to simplify this, I'll start off with a simple example. In our given example, temperature is given as 300 degrees centigrade and internal energy is given as 1332 kilojoule per kilogram. First, since the temperature is given, I'll look at my saturated water temperature table and I'll try to find 300 degrees centigrade here. So if we look at when the temperature is 300 degrees centigrade, then our internal energy is so our UF is 1332 kilojoule per kilogram, which means we have the given internal energy the exact as what we just found in the table, which means we are at the saturated point. If we look at the graph, this will be our saturated point and our quality factor would be 0, and we're gonna add our quality factor to our table, which would be 0. Moving on, so our phase would be saturated liquid phase, liquid point. Now we'll have to find pressure. Simply, we'll come back to our saturated temperature water table and we'll look at the saturated pressure, which is 8.581 megapascal. And we'll pick that value and put it in our solution. The value, although is in megapascal and the table is in kilopascal, we'll have to transform the value. But here we are done with our first problem. I'll start with my second example, in which I'm given my pressure, which is 600 kilopascal, and my internal energy, which is 3477 kilojoule per kilogram. Since the pressure is given, I'll right away look at my pressure table and I'll try to find the pressure where it's 0.6 megapascal here. Since 600 kilopascal is equal to 0.6 megapascal, and from here, if we look at the internal energy, which our UG is 2567 and what's given is 3477, which is way greater than what's on the table, which means we are in superheated vapor region. Here's the region where we are in right now. So now we'll jump right away to our superheated table and we'll try to find where the pressure is 0.6 megapascal. Here we found, and if we look for the internal energy, which is 3477 kilojoule per kilogram, this is the exact value what's given here in our problem, which means our temperature is 700 degrees centigrade. We'll pick that temperature and put it in our solution, and we're done with finding temperature. Here, in order to find the quality factor, since we're in the superheated vapor region, quality factor only exists when we're in between superheated and compressed, which means when we're in the mixture. And in our case, we're in superheated, so it doesn't exist. So we'll just put a dash. And here we are, and yes, the phase would be superheated. Yes, and here we're done with our second example. I'll let Hamza handle the other two examples.
Perfect. So for the third example, we have that the temperature given is 150 degrees Celsius and the internal energy is 1595.63. So first step is to go to the temperature tables and look for 150 degrees Celsius. So we have here 150 degrees Celsius, and we have that the data we have is between UF and UG, so we are in a mixture phase. In order to find the X, which is the quantity, we know that we are between the saturated liquid point here and the saturated vapor point here. So we have a x, we have a quality. To find the quality, we need to use this formula, which is U equals to UF plus X UFG. UF and UFG are given by the tables here in 150 degree, and the U is given in our example, which is 1595.63. So by having to do a small mathematical calculation, we find that X equals 0.5. For the pressure, we take it in the saturated table because we are in a mixture. So in the mixture, we have the same saturated pressure, which is 0.4758. 0.4758. And remember, it's in megapascal. So after, we have to change it to kilopascal. For the last example where we are covering today, we have the temperature that is 60 degree and the pressure 200 kilopascal. First step is to go to the temperature table for 60 degree. 60 degree, we see that the saturated pressure is 19.940. We have 200, so we have a lot more. We know that we are in the compressed region. The phase is compressed region. If you want to show it in the diagram, the TV diagram, we see that we are in compressed region, which is we didn't achieve the saturated liquid point yet. So to find the X, we know that there is no X applicable because we are not in the mixture, so no X is here. And to find the U, we go to the compressed table and look for 60 degrees Celsius and 200 kilopascal. Compressed, yeah. So we see that the pressure starts at 5 megapascal. So we don't have the 0.2 megapascal in the tables. We have to take in consideration, we have to go back to the saturated tables and take the U value we're looking for as the UF value. So we go back to 60 degree at the same temperature, 60 degree. We go back at 60 degree and we have the pressure, and now we have to take the UF, which is 251.11 as the U. 251. This is 251. Yes. Perfect. And this is the end of the problem. So nothing very complicated. It's small steps that you have to follow, and the rest is done. So thank you guys for listening, and have a good day.